Okay, so there's an example from the textbook that I'm sure you will read, but I thought it would be a good one for me to kind of explain a little bit, just in case the textbook is a little confusing. The textbook has a nice way of explaining this example, and I'll show you that in a moment. But I wanted to also kind of run through it in my own way, because what I like to do, if I'm given something in prefix or postfix notation and I want to try to interpret it and figure out what operation it is, what algebraic expression it is trying to convey, I like to first convert it into a tree. So I'm going to show you how to do that. So given this is prefix notation, I am seeing the operations occurring first near the beginning here, and then operations are followed by their two inputs. So each binary operation is followed by the two inputs that it would require. But that structure is nested and in sort of recursive. So I'll show you how we can build this. I'm going to start my tree with the plus operation. Now the plus operation is a binary operation. It needs two inputs. And I'm going to go, and it's ordered, so I'm going to go input on the left followed by input on the right. Now the input on the left is a difference, so that would be subtraction. Now the subtraction is a binary operation which requires a left and right input. And the left input for that subtraction is a product. There's my multiplication. Notice I'm going, this is prefix, so self first, right? So each operation is listed first, and then I go left before I go right. So, so my multiplication is a binary operation which needs two inputs, and those inputs are 2 and 3. So here we go. We have 2 and 3. So now after we've said the product of 2 and 3, now 5 is the other input for this difference. So we're subtracting 5. And then the other input for this sum is my next character, which is itself a quotient. So I have to divide two things, and that's got two inputs. So my quotient, the first of its inputs is an exponential expression, which has two inputs. And that exponential's inputs are 2 and 3. So here's a 2 and a 3. And then the other input for the division is a 4. Woo! So that was reading through this prefix notation and using it to build a tree, always going, going in the order that the pre-order traversal does. Right. Okay. Now I've got my tree. Now from that, it's a little easier to figure out the infix notation, which is the traditional one. So we're going to now traverse this tree in order traversal. So that would be left and then middle and then right. So we'll start by going all the way down the left, get to 2. And on the way back here, we'll do times and then 3. Now before I go on, when you are doing infix, when you're doing the in order traversal, remember this is the one that needs parentheses in order to be unambiguous. So whenever we complete a binary operation, I'm going to put parentheses around it. So 2 times 3, I'm going to put parentheses right there to indicate that those are the inputs for that multiplication. So now we're going to come up to, so now we're done with this left subtree over here. We're going to come up and print that subtraction, and then go to the right and print that 5. And now we've completed another binary operation, so I'll put parentheses around that. All right. Back up the tree, we'll go return to the subtraction, and then return to the addition. And now, since that addition node is now done with its left subtree, now it prints itself before moving on to its right subtree. All right, the right subtree is a division. So for that division, we need to go left first, but that exponentiation needs to go left, and we get 2, and then we'll do 2 raised to the power 3, right? So printing that power symbol on the way back up before it goes right. That's a binary operation, so I'm going to enclose it in parentheses. And then head back up again. Now we get back up to the division, and the division symbol prints before going off to the right, and I print 4. Now that binary operation is complete. I put parentheses around that. And then 4 is done, it returns to division, which is done, which returns to addition, and it's done. So now I've finished the addition operation, and this is kind of superfluous. You don't really need to do this, but I'll put parentheses around the whole thing just to finish it all off. So there we go. So so that was how to turn it into a tree and then reinterpret it in infix notation with the parentheses going in the correct places. So now I can actually evaluate this. This is 6 minus 5 plus 2 cubed, which is 8, divided by 4. And I get 1 plus 2, which is 3. Now I just want to show you how the textbook explains this as well. So let's see if you can see that okay. Yeah, there we go. So figure 12 here is showing us a similar idea. So this is the same expression in prefix notation, and they describe interpreting the prefix notation from right to left. It's a little confusing what they mean by that, but what they mean is starting from the right-hand side, look for the first operation symbol and apply and sort of evaluate that operation. So the first operation is the exponentiation, and its inputs are 2 and 3. So that is evaluated to 8, and then we can replace that whole chunk there with an 8. And then the resulting string, now its rightmost operation is the division, and its inputs are 8 and 4. So we perform that operation to get 2 and replace that entire chunk with 2. Now the result here, its rightmost operation is the multiplication, so perform that and replace. Now we perform the subtraction and replace, and then finally you perform the addition and you get 3. So that's an example of how you do it, and that method is pretty cool. I mean, this also can be applied to postfix notation, to interpreting postfix notation, except in reverse, where you're starting with the leftmost operation, multiplication, and looking at, instead of the following 2 characters, you look at the preceding 2 characters to evaluate that operation. So this is this product, its inputs are 3 and 2, right, from the left. All right, so that about does it for section 11.3. You're gonna practice some of this on the homework and in the assessment, and I hope you have a little bit of fun with it. I'll see you next time.